We just continue our topic today, that is waves. We already seen about the transverse and longitudinal waves. So starting from transverse and then longitudinal waves. Transverse and longitudinal waves. Uh, for understanding a transverse and longitudinal waves, in order to understand what is the difference basically in transverse and longitudinal waves, we can consider a particle in a medium. Let us suppose this is a particle P. Now, we have two types of vibrations in this particle. One is up and down, that can be vertical vibrations, and one is to and fro, that will be horizontal vibrations. This will be up, this will be down, this will be to, and this will be fro. When the particle is doing up and down vibrations from its mean position, then these vibrations are called vertically vibrations. And when particle moving to and fro from its mean position, then these types of vibrations are known as horizontal vibrations. Now, in the case when the particles are vertically vibrating from its mean position, the waveform formed is known as transverse waves. So here I can write transverse, and the situation when particle is horizontally vibrating from its mean position, then the waveform formed by them are known as longitudinal waves. So here you can say the waveform formed by such kind of vibrations of particle are known as longitudinal waves. So this is the clear-cut difference between the longitudinal and transverse waves. In case of longitudinal waves, how the waveform travel the energy from one point to another point. Let us suppose these are the medium particles. Okay. Now, when this particle vibrating horizontally, then it will collide with this particle, and there is a situation when both these particles are at this point. Okay. Now, by getting the energy from this particles also vibrate from this direction. Okay. Now, when this particle moving to its true direction, this particle get its flow direction. That means when this particle moving towards the right direction, this particle gets back to its mean position. That means the first particle disturbing the second particle from its mean position. Okay, and by doing so, that it will be returned from its mean position back. Now this particle comes here also, and by getting the energy from the first particle, this particle moves in this direction, and there is a situation when both these particles at the same place, and by colliding the second particle, this particle is also get the energy, and this energy it will transfer to its fourth particle. Okay, now we can see the same procedure follows for till all the energy is not collapsed due to the friction between the particles. Okay, now this is the traversing of a longitudinal waves. Now we can take another example here. If we have a stretch string like this over here, and if we are vibrating this end of this string, then what we have, let's suppose this waveform start traveling towards the tie end with velocity v. Okay, now this is a cross section area for the where the pulse are generating basically. Let's suppose this. Now here what we can see, a single pulse is sent along a stretch string. This is a typical element of the string, such as the marked with a dot, moves up and then down as the pulse passes through the element. Motion is perpendicular to the direction in which the wave travels. Let us suppose there is a dot in this string. As soon as this pulse reaches to this point, this dot is moves upward first, then downwards. Okay, and this motion it shows that the particle is or dot is vibrating from its vertically direction, that will be perpendicular for its mean position. That means a transfer wave is generated over here. So we can elaborate the figure. A single pulse is sent. This is a situation when a single pulse is along a sent along a stretched string along a stretched string. A typical element of the string a typical element of the string, such as that marked with a dot, that marked with a dot, moves up and then down, moves up and then down as the pulse passes through. As the pulse passes through. Now the element's motion is perpendicular to the direction in which the wave travels. Here, the element motion is is perpendicular to the direction is perpendicular to the direction in which the wave travels, in which the wave travels. Now, if you move your hand up and down in continuous manner, a continuous wave travels along the string with a velocity v. However, the motion of your hand is a sinusoidal function of time. At any given instant of time, the wave will have a sinusoidal shape as shown in this figure. Now, we can design another figure. We can also design one more diagram for this. By extending figure 1, what we have? Let us suppose this is a string, and then we have vibration like this, and this will be a continuous function. This will be a pulse head. The particle vibration is in this direction, that will be a perpendicular of the wave propagation direction. Here again we have particle direction vibration is vertical, and the sinusoidal wave is related wave, and this has a velocity v from this direction. This is x axis and that is this y axis. Here in this figure, what we have, a sinusoidal wave is sent along the string. A typical element of the string moves up and down continuously as the wave passes, and it is a transverse wave, as we already discussed. Wave is sent along the string, along the string. A typical element of the string a typical element of the string moves up and down, moves up and down continuously as the wave continuously as the wave propagating wave passes In next class we will discuss more about the transverse and longitudinal waves, their propagation and the displacement relationship in a progressive wave.